Okay, so we're going to be doing our second day with washers. So this is very similar. Matter of fact, the problem we did with discs, I just changed the axis of rotation. Okay, so I always tell my kids, hey, start off by graphing these things. Okay, so basically when you graph this, you're going to end up getting your vertex, which is at 2, 1, 2, 3. It opens down, so 1, 1, 2, 1, 2, 3, 4. So here and here. Here. So this ends up being your area. We're revolving it around this line, which is y equals -3. So one way of doing this is reflecting this parabola over that. So reflect those 2 points, and this part will look something like this. And as it rotates, get that, and then if you see this point here, so this rotates the inner part like that, this outer part comes down here and goes around. Okay, and that shows you kind of that we have that disc there. So if we look from here to here, that is our r of x. Okay, that's our outer radius. From here to here, that is our little r of x. Okay, so if I write these down, that means my r of x, the top function is this function, -x minus 2 squared plus 3, minus my outer, or my bottom, and when you simplify, you get -x minus 2 squared plus 6. Now, my little radius ends up being -1 minus -3, because this is that y equals -1, this is that y equals -3, which means my little radius is 2. Okay? So both of them, my bottom function ends up being my axis of rotation. Now, since we know we're doing our horizontal axis, we're using this equation. Big R squared minus little r squared dx. And we just plug in. So our upper and lower limits are going to be, our volume starts here at 0 and ends here at 4. Basically, it's the starting and stopping points of my bounded area. So 0 to 4. And again, my big radius is -x minus 2 squared plus 6, all of that squared, minus 2, which is my little radius, squared. Okay, and then you're going to FOIL all that out, or if you wanted to, you could split it up and you could do integration by substitution, which would be really easy, but I don't want to do that, so I FOILed it all out. When you do, you get this. And your volume ends up being 384 pi over 5. Okay? So basically, the only difference between the problem with washers and the disc problem is in the disc problem, your axis of rotation was right here. I had no gap. And basically was just this equation right here. The -x minus 2 squared plus 3. But now that we have that gap, we're basically taking the total volume and subtracting out this cylinder. So this part right here represents the cylinder, that piece that we're actually subtracting out of the middle, this piece. And you can see it here, this is just a giant cylinder gouged out from the center. Okay? But that's how you set up washer problem.